Welcome to a lesson with Dr. Powell. Let's look at an example where we have a system of different shapes. Maybe we have a square over here, and let's suppose we have a triangle over here, and maybe a half circle over here. Suppose, for instance, that we know that, and this is an isosceles triangle, say, and the center of this isosceles triangle, let's suppose is at a coordinate of 3. Maybe this coordinate right here is at -1, and maybe the x coordinate here is maybe like um, is maybe -2. So the and also let's suppose that we have different areas here. Maybe this area right here um, is pi halves. Maybe this area up here is an area of 1.5. Maybe this area over here is an area of 1. The question is, what is x bar? Well, assuming that we've assigned these coordinates to be kind of geometrically centered in these are actually the x bars of the individual shapes. What's the x bar of the whole system? Like this whole system where we're held together by some like negligible plate or surface or something like this. This would be the location where we put our finger in that negligible mass surface in order to hold all the objects up um, and balance them. So let's think about how that would go in our calculation. We're going to use a weighted average. What percentage is this of the total area that I see right here? Well, 1.5 is, well, it's 1.5 over the total sum. Let's just kind of say the total sum is 1.5 plus pi halves plus 1. So 1.5 divided by a would be the percentage here, and we multiply it to -2. Then we add the percentage for pi halves. So pi halves over a multiplied by -1. And we add to that the percentage for this guy, which is 1 over a times the coordinate of 3. Now this is a weighted average, and it'll yield what x bar is. Notice that this percentage plus this percentage plus this percentage will be equal to a percentage of 1, or 100%. And we're applying it to these different values to see kind of how it balances or averages out. Now, in making this calculation, let's go for it and see what happens. So -2. So let's see. We'll have one of, we can factor the 1 out of a over a out of all of that, and so we have -2 times 1.5 is -3. And then we have a minus pi halves times 3, or so we have plus 3 here. Okay, notice that this -3 and that 3 cancel, which is really nice. And we're just left with negative pi halves right here over a. And so the x bar will actually be equal to negative pi halves all over a. Now we can rewrite a as being 2.5 plus pi halves, or which is the same thing as 5 halves plus pi halves. Now we can multiply top and bottom by 2 in this fraction. So this again was just rewriting of a here. Multiply 2 top and bottom. So we'd end up getting that x bar is actually equal to negative pi all over 5 plus pi. So this would be the x bar of the region. Computing this, we get 5 plus pi. Let's, in your mind, just imagine that pi is like something like 3. So this would be like 8 on the bottom and -3. So kind of approximately like -3/8. So it's going to be, so the center of the system is on this side of 0, but over here just a little ways. That's kind of what we're looking at for where the center of mass would be for this particular system. Thanks for watching.